It is a January morning in Holmes County, Ohio. The thermometer nailed to the porch post of my neighbor Earl's place reads 11 degrees Fahrenheit. His propane tank is down to a quarter. He called the delivery company on Monday. They told him the soonest they could come was Friday. It is Tuesday. He has a wife, 3 children under the age of 10, and a greenhouse full of seedlings he has been tending since October that will be dead by Thursday morning if the temperature inside that greenhouse drops below freezing one more time. He has a space heater plugged in out there, running off an extension cord. His electric bill last month was $340. The month before that, it was $290. He is choosing, right now, between heat in the house and heat in the greenhouse, because he cannot afford both. I have been watching this happen to my neighbors for years. The propane prices go up every winter. The electric rates go up every year. The delivery windows get longer, and the bills get heavier, and the people on the other end of all of it, the families trying to stay warm, the gardeners trying to keep their plants alive through a hard Ohio winter, they just keep paying because nobody ever told them they did not have to. Now, I want you to sit with this. There are 3 methods, all of them old, all of them free to run once built, that together can heat a home or a greenhouse through a full Ohio winter with no propane, no electric, no monthly bill of any kind. The physics behind each one is real and documented. The history behind each one goes back further than this country does, and the only reason most people have never heard of any of them is that nobody profits from a house that heats itself. My name is Amos Miller. I am Amish, and I farm in Holmes County, Ohio. My family has been farming this ground for 4 generations. The farmhouse I live in, with my wife Rachel and our children, has no furnace. It has no propane line. It has no electric baseboard heaters. It has never had any of those things. We have come through every winter this county has thrown at us, including the ones that cracked the pipes in the houses on either side of ours, using exactly the methods I am going to walk you through today. The main method, the anchor that makes all the others possible, and then the 2 supporting methods that compound the effect and extend it into spaces a house never naturally reaches, including that greenhouse. By the end of this, you will understand how heat actually moves, why your house loses most of it in the places nobody is looking, and what to put in those places instead that has been holding heat for farmers and families since long before electricity was a thing anyone had thought of. Before I go further, for the folks who want all of this, every method I have shown, every old skill, every honest piece of homesteading knowledge gathered together in one place, I have put it all in a book at amosmillershop.com. The book is the long version. If you want it, it is there. I will not mention it again. Now, the main method first, and before I describe it, let me tell you why it works, because once the physics make sense to you, the whole thing will be plain, and you will see immediately why it is so powerful. Stay with me. Heat moves in 3 ways. Conduction, which is heat traveling through solid material, the way a cast iron pan gets hot when you set it on the stove. Convection, which is heat moving through air or water, the warm air rising, the cold air sinking, the slow churn you can see above a wood stove on a cold morning. And radiation, which is heat traveling, as invisible waves, the way the sun warms your face through a car window, even in February, when the air outside is freezing. Every heating system in your house, whether it is a furnace, or a boiler, or a wood stove, or a space heater, is producing heat by one of those 3 methods. What most people never think about is how heat leaves. And it leaves, almost always, through the same mechanism it came in. Conduction through the walls and the roof. convection through gaps, and drafts that let warm air escape and cold air enter, and radiation through glass. Understand where the heat is going, and you know where to stop it. Understand how to store the heat you do produce, and you stop needing to produce as much. That second part, heat storage, is what this whole method is built on, and it is the thing that the modern heating industry has never found a way to sell you, which is why you have never been told about it. The method is called thermal mass. It is not a product. There is no brand name for it. You cannot buy it in a store. Thermal mass is simply the capacity of a dense, heavy material to absorb heat slowly, hold it for a long time, and release it slowly back into the air around it. Stone holds thermal mass. Brick holds it. Concrete holds it. Clay holds it. Water holds more thermal mass per pound than almost any solid material on Earth. This is not new science. It is old as the first person who noticed that a stone warmed by a fire in the evening was still warm when they woke up the next morning. The entire tradition of the masonry stove, which my people have been building and using for centuries, and which was standard in farmhouses across Central Europe long before it arrived in America, is built on this single physics principle. You put a small amount of wood through a hot, fast, complete burn. The fire is intense and brief. The heat from that fire does not go straight up the chimney, the way it does in a regular iron stove with a thin metal body. Instead, it travels through a long, winding, internal channel built into several hundred pounds of fired brick. By the time the hot gases finally reach the chimney opening, they have given up most of their heat to the mass of brick surrounding them. The brick absorbs that heat and holds it, and then, for the next 12 to 18 hours, sometimes longer, it releases that heat slowly and steadily back into the room, the way a stone does after a summer day, long after the fire has gone cold. A standard American cast iron wood stove, the kind most people think of when they think of heating with wood, works on a fundamentally different and less efficient principle. It is all convection. The iron body heats fast and radiates heat fast, which feels good when you are standing next to it, but the iron also cools fast. The moment you stop feeding it wood, the room starts cooling down. You are chasing the temperature all day, adding wood every 2 or 3 hours to keep the stove hot enough to keep the air warm. A masonry heater fires once, maybe twice a day. The brick takes the heat and keeps it. The room stays at a steady, even temperature without anyone tending it. This is what my grandfather heated his house with. This is what his grandfather heated his house with. And if you walk the old farmsteads in this part of Ohio, or down into Pennsylvania, or up through the German-settled townships of Indiana, you will still find them standing in the oldest rooms, these massive blocks of brick and tile and mortar, cold to the touch in July, and radiating a dry, even, bone-deep warmth in February that no forced air furnace has ever matched. Now, building a full traditional masonry heater from scratch is real masonry work, and it is a multi-week project. I am not going to pretend otherwise, but the principle scales down and can be adapted, and that adaptation is where this becomes immediately useful to most people. The scaled-down version, the one you can build yourself for the cost of materials and a weekend of careful work, is a rocket mass heater. The name sounds modern, and people often assume it is a recent invention. It is not. It is an application of principles that go back centuries, organized and documented by engineers who studied traditional mass heating in the 1970s and 80s, when the first energy crisis made people interested again in what their great-grandparents already knew. The rocket mass heater burns wood in a J-shaped combustion chamber, a short horizontal feed where you load the wood, and a tall vertical rise where the draft pulls the fire upward. because the air is being drawn hard and fast up that vertical rise. The combustion temperature inside is extremely high, far higher than a conventional wood stove. Higher temperature combustion means more complete burning, which means less smoke, less creosote, and far more heat produced per pound of wood. Most rocket mass heater builders report using 1/4 to 1/10 the wood of a conventional stove to produce the same or more heat. The hot gases from that combustion chamber then travel through a long horizontal channel before reaching the chimney. That horizontal channel is buried in a mass of cob, which is a mixture of clay, sand, and straw, or concrete block, or brick, depending on what you have and what you are building. The mass absorbs the heat from the gases traveling through it. The exhaust that finally exits the chimney is barely warm to the touch because nearly all of the heat has been deposited into the mass, and then for the next 8 to 12 hours, that mass, which can weigh several hundred pounds, depending on how large you build it, radiates its stored heat steadily into whatever space surrounds it. The cob body of a well-built rocket mass heater reaches temperatures of 150 to 200 degrees Fahrenheit internally during firing and holds surface temperatures of 90 to 110 degrees for many hours afterward. That surface warmth is radiant heat, the same kind of warmth you feel from the sun or from a fireplace, and it warms people and objects directly without first having to heat all the air in the room. It is a gentler, more efficient warmth. It does not dry out the air the way forced air does. It does not create cold spots near the floor the way convective heat does, because radiant heat does not rise the way warm air does. It travels in waves from the surface of the mass in every direction equally. You feel it on your skin the way you feel sunlight. My grandfather used to say that the heat from a good masonry stove was the kind of heat that went into your bones. He was not being poetic. He was describing radiant heat transmission and the way dense materials at moderate temperatures warm the human body more efficiently than hot air does. And he knew it from 50 years of winters without a thermostat. The cost of materials for a basic rocket mass heater, meaning the J-tube combustion unit, the horizontal run, and a modest mass body of a few hundred pounds of cob or salvaged brick, runs somewhere between $0 and a few $100s, depending on what you can find and what you have to buy. Clay subsoil dug from your own ground, mixed with sand and straw, costs nothing but the digging and the mixing. Salvaged brick from a demolition yard costs very little. The J-tube combustion chamber itself is often built from standard fire brick that you can buy at any masonry supply house, and it does not take many. There are plans in books and free online from people who have been building and refining these for 40 years. The design is not proprietary. Nobody owns it. That is, again, the reason the heating industry is not going to put it on a billboard. Now this is where the second method enters, and it is the one that takes the heat from your house or your living space and carries it to a place a house cannot naturally reach: a greenhouse. The method is a heat sink connected to a solar collector, and it works on the same thermal mass principle with water as the storage medium instead of brick. Water, as I mentioned, holds more heat per pound than almost any solid material. Specifically, water holds about 5 times as much heat per pound as the same weight of concrete, and about 10 times as much as the same weight of dry wood. This extraordinary capacity to absorb and hold heat is what makes it the ideal thermal mass for a greenhouse application. The setup is straightforward. On the south-facing wall of your greenhouse, which is the wall that receives the most direct winter sunlight, you place a row of dark-colored water containers. old 55-gallon plastic drums, black or painted black, large black rubber stock tanks, dark plastic barrels, even gallon jugs filled with water and painted black if that is what you have. The color matters because dark surfaces absorb solar radiation more completely than light surfaces. A black surface in full winter sun can reach surface temperatures of 80 to 100 degrees Fahrenheit on a clear day, even when the air outside is well below freezing. The water inside those black containers absorbs that solar radiation all day. By mid-afternoon, on a clear winter day, the water inside a well-positioned black barrel in a south-facing greenhouse has absorbed an enormous amount of heat. It does not feel scalding to the touch, maybe warm, like a bath that has sat a few minutes, but the volume of water holds that warmth with tremendous stubbornness. Long after the sun goes down, long after the air temperature in the greenhouse would naturally drop below freezing, those barrels are still releasing the day's warmth back into the air around them. They are a thermal battery that charged itself for free all day and is now paying it back through the night. The sizing is worth knowing precisely. A single 55-gallon drum of water in a south-facing position in a greenhouse will store enough solar heat to raise the overnight low temperature of a small greenhouse, roughly 10 feet by 16 feet by 15 to 20 degrees Fahrenheit, compared to what it would otherwise drop to. If your greenhouse would naturally hit 22 degrees overnight, the water mass keeps it at 37 to 42. If it would hit 28, the water mass keeps it at 43 to 48. In most of Ohio, that difference is exactly the gap between plants dying and plants surviving. 2 drums compound the effect. 4 drums, properly placed along the south wall, can maintain a greenhouse at temperatures 30 to 35 degrees above the overnight outdoor low on most winter nights, without any fire, without any electricity, without any fuel of any kind. Just the free heat from the sun, captured and held in the simple thermal mass of dark water. The upfront cost of 4 55-gallon plastic drums, if you buy them new, is around $40 to $60 each, so $200 to $300 all in. More often, you can find used food-grade barrels at food processing facilities, car washes, or feed stores for $5 to $15 each, sometimes free. This is a one-time cost with no ongoing fuel expense and no moving parts to wear out. The same principle, scaled up appropriately, can extend the heating season in a greenhouse by 6 to 8 weeks at both ends of the year. You start your seedlings in late February instead of April. You keep frost-sensitive plants alive into December. The growing season that Holmes County's climate would otherwise allow becomes something dramatically longer, which is not a small thing for a family that depends on that greenhouse for food or for income. The third method is the one people walk past without seeing, even though it is right in front of them. It is the ground. Not in a poetic sense. Literally, the ground under your feet. At a depth of 4 feet, in this part of Ohio, the soil temperature stays at a remarkably consistent 52 to 56 degrees Fahrenheit year-round. In January, when the air outside is at 11 degrees, 4 feet underground, it is 54. In August, when the air is 95, 4 feet underground, it is still 54. The Earth itself is a massive thermal mass, storing the average annual temperature of the climate and holding it with a steadiness that no mechanical system can match. The method for using this is called an earth tube, or sometimes a ground-to-air heat exchanger, and the concept is not complicated. You bury a length of large diameter pipe 4 feet deep in the ground. One end of that pipe opens to the outside air. The other end opens into your greenhouse or into your home. When cold outside air is drawn through that buried pipe, the pipe is surrounded on all sides by ground that is 54 degrees. By the time the air travels through 20 or 30 feet of buried pipe surrounded by 54-degree soil, the air coming out the other end is significantly warmer than the air that went in. On a day when the outside air is 11 degrees, air traveling through a properly sized earth tube arrives inside at 35 to 45 degrees Fahrenheit, depending on the length of the tube and the flow rate. That air is still below room temperature, but it is no longer dangerous to plants, and it is air that cost you nothing to warm. Partway, the earth did the work for free. For a greenhouse application, this is particularly powerful because the temperature range you are trying to maintain is narrower than for a living space. You do not need 68 degrees in a greenhouse where hardy seedlings are overwintering. You need above 32 degrees, or better yet, above 40. An earth tube system bringing in 40-degree air instead of 11-degree air means your water barrels and your small supplemental heat source, if you have one, are fighting a much smaller battle. They are not trying to heat from 11 to 40. They are maintaining what the earth tube has already brought most of the way there. The materials for a basic earth tube are a length of rigid or corrugated drainage pipe. 6 inches in diameter is a minimum. 8 inches works better. Buried in a trench 4 feet deep. The trench does not need to be long to make a significant difference. 30 feet is where you start to see strong results. 60 feet approaches the maximum benefit the ground temperature can deliver. In many places, in Holmes County, the slope of a hillside means you can run a trench along a natural grade without extensive excavation, the way the old farmers ran their spring houses along stream banks. The total cost of materials for a modest earth tube system, the pipe, the fittings, and a simple screened intake on the outside end to keep animals out, runs somewhere between $100 and $300 depending on pipe diameter and length. The labor is a few hours with a rented trencher or a long afternoon with a spade and a strong back. Once it is in the ground, it requires no maintenance, uses no electricity, and keeps working for as long as the pipe lasts, which for quality drainage pipe is measured in decades. Now let me put all 3 of these together, honestly, the way the old farmers counted their costs, which is to say, plainly and completely, a rocket mass heater built from salvaged brick and homemade cob, material costs under $200 for most people, often under $100 if you have clay subsoil on your property and can find used brick. A set of 4 55-gallon black water barrels positioned along the south wall of a greenhouse. Material costs $50 to $200 depending on whether you buy new or find used. An earth tube, 30 to 60 feet of 6-inch drainage pipe buried 4 feet down. Material costs $100 to $300. Total outlay for all 3 systems combined under $600 for most people, often significantly less. Against that, the average American family in a cold climate like Ohio spends somewhere between $1,000 and $2,000 a year on heating fuel alone, not counting the electric bill that heaters and fans and thermostats add. The math of the first winter speaks for itself. The math of the second winter, and the 5th, and the 20th, with none of those bills coming due, is something different altogether. But here is the part that goes beyond the math, and is more important than the money. And it is the part I want you to sit with before you go. My neighbor Earl, the one I told you about at the start, is at the mercy of 2 companies and 1 delivery schedule for the most basic thing a family needs in January: heat. The propane company sets the price. The electric company sets the rate. The delivery truck sets the schedule. He has no part in any of those decisions and no way to change any of them. When the price goes up, he pays it because what is the alternative? When the truck cannot come, he waits because what is the choice? That dependence, that helplessness at the exact moment of the year when you need warmth the most is not an accident or bad luck. It is the designed condition of a system that profits from monthly payment and has no financial interest whatsoever in the permanent solutions I have described to you today. A house heated by a masonry mass and managed by a family that understands how heat works, sends no monthly check to any company. A greenhouse kept alive through February by solar water mass and ground-warmed air owes nobody a bill. These systems belong to the person who builds them. They cannot be repossessed. The fuel company cannot raise the price on the wood you cut from your own land or the sunlight that falls on your own south wall. The earth under your feet maintains 54 degrees, regardless of what is happening to the energy market. That stability, that ownership, that independence from a monthly bill for a thing as old and basic as warmth is what my family has had for 4 generations on this land, and what every family on every piece of ground in this country could have if someone would just tell them how. That is the only reason I am standing here telling you. Tell me in the comments below, what is your heating bill this winter, and what is the coldest your greenhouse has gotten on a bad night this January. I want to know where you are and what you are dealing with, because the folks who read these comments come from all over the country, and the range of climates they are working in is something I learn from every single week. I read everyone. And if someone in your family, a grandparent, an old neighbor, a great uncle who farmed in the years before propane was common on every road, used any version of what I have described today, a masonry stove, a root cellar kept warm by the ground, a greenhouse banked with old windows, and hay bales, tell that story here. Those memories are exactly the kind of knowledge that disappears when nobody writes it down. Next time, since we have been talking about the heat you can make and store for free, I am going to show you the old method my family uses to insulate a cold frame and a root cellar with nothing but straw, a few boards, and the physics of dead airspace. No spray foam, no fiberglass bats, no licensed contractor, just the oldest insulating principle in the world and the materials you likely already have on your property. It is the natural next step from everything we covered today. Subscribe so you do not miss it. Until then, bank your heat, trust the earth, and remember that the people who built this country with their hands kept warm through winters harder than ours without a single monthly bill and without asking anyone's permission. That knowledge did not die. It is still here. You just remembered some of it today.